Hi, in this video I'm going to show how to track a face using the color of the nose and the computer vision toolbox from MATLAB. In this video I'm going to use a cascade object detector to detect the face and the nose, and based on the HSV color format and the histogram based tracker, I'm going to track the bounding box. In the previous video, which is in a link in the description of this video, I used the point tracker, which uses the Canade-Lucas-Tomasi algorithm, which depends on the points of interest within the face. Unlike in that video, the histogram based tracker uses the colors rather than the points of interest. Okay, so let's take a look at this example. The article is linked in the description of the video as well. So we hit open script and that'll take us to the MATLAB desktop, and we can start running it. And we're gonna create a cascade object detector, which by default detects a face. Let's read a frame from the video reader and use the step method from the cascade object detector that takes as an input the image, and from that we get the bounding box of the face, x mean, y mean, weight and height. And that bounding box, we're gonna put it using the insert object annotation into the video frame to display it just to make sure that we detected the face. And now, usually in computer vision for analysis, the RGB color format is not convenient. It's more convenient to use the HSV format, and for that there's an image. This should be from the image processing toolbox, yeah. And with that function we get the hue channel. So let's displace the hue channel just to see how it looks. It's quite ugly, but it's convenient for computations. So now let's create another cascade object detector. This one is for the nose, and it's gonna use a region of interest. The region of interest is passed during the step function, so it's passed along with the new image. This is the image and the bounding box. We take the first one, although it's only one because we only detected one face, so this doesn't make a difference. But but this just in case you detected more than one. Okay, so we have the nose detector, we pass the image, and the bounding box, the region of interest, and we're gonna get the bounding box corresponding to the nose. And in this case, we have a couple of matches. Usually the best match is the first row, so that's why we're gonna pick the first one in here. And we're gonna create a histogram based tracker, and we, as in the case of the point tracker, we have to initialize it. We initialize it with the image. In this case, the image is going to be the hue channel image, and the bounding box, which is the nose bounding box. And unlike the point tracker, there's a few more differences. One of them is that the point tracker tracks points of interest, and the histogram based tracker is tracking a full bounding box. So we read the next frame and convert it to the hue channel, and just pass the hue channel to the tracker, and the tracker is, instead of returning us the points as in the point tracker, it just returns the new bounding box for the new image. So let's just put it into insert object annotation along with the new image. And there's another good difference, is that in the point tracker, once you detected the new points have to be set again in the tracker, but you don't have to do that in here. I mean, he keeps track of where the bounding box is, which is good design, I think. Okay, so now we annotated the image, and we just put it into the video and let it run. So let's just run it. And at the beginning, the bounding box belongs to the nose because that's where we got it. We got it from the nose, but this is gonna be smart enough to use the color of the skin to expand the bounding box until it covers the face. So that's it for the video. Thank you very much for watching.